Okay, so this is a question about nuclear fusion, mass defects, etc. So we've got this fusion reaction where 4 hydrogens become a helium. Some of the electrons in the atoms go into making this, some of the protons into neutrons. Right? The problem is hydrogen, so our mass defect, right? It's the mass of a helium minus 4 times the mass of a hydrogen. Those numbers are given in the question, so we can work out that difference. Right. These are very small differences you need to keep all the significant figures you're given throughout the working of these, right? If I just say it's 4.0 minus 4 times 1.0, I'm going to get no thing of interest. Alright, so our difference is minus 0.028697 units. So, because this mass is negative, because every fusion, some mass is turned into energy, the mass of a sun is decreasing over time. Alright, so we're going to convert energy lost again into joules. Right? The simplest way to do that is to convert the mass change into kilograms and then use E equals mc squared, the mass energy convergence, to calculate the equivalent energy. So we're going to multiply by the conversion factor, but 0.03 units is a tiny mass, so you want to multiply it by that tiny number in the conversion factor, right? Think about whether you're aiming for a big or small number. Which will help you multiply and divide by these conversion factors. Right, so our energy released, delta M times C squared, so we multiply by 3 by 10 to the 8 squared, that number's on your formula sheet, and we get a tiny amount of energy, but not a trivial amount. 4.287 by 10 to the minus 12 joules per helium created.